Assalamualaikum warahmatullahi wabarakatuh. My name is Afam Muhammad Shukri. My metric number is DF230130. We are from Group 2, Section 3. We present about our project Hydrology. Location of our project is we choose at Sungai Perak, Kuala Kenderong. This is our group member. First, me, Safam Muhammad Shukri. Second, Muhammad Salim bin Sobri. Third, Muhammad Syakidina bin Rahim. And last, Muhammad Adi Ishak bin Zamri.
Hello, my name is Muhammad Adib Syam Zamri, metric number DF230058, and I'm here to present about our introduction of our project. Malaysia tropical climate and diverse habitat makes catchment region essential for managing water supplies, supporting agriculture, industry, and residences. The topography with hills and river system form complex catchment crucial for flood mitigation, environmental conservation, and hydropower production. Efficient management, including vegetation preservation and pollution control, ensures sustainable water resources and biodiversity. Key hydrological processes: precipitation, infiltration, runoff, groundwater flow, and evapotranspiration are influenced by terrain, soil types, and climate. Understanding this factor is vital for addressing urbanization, climate change, and preserving Malaysia's water resources. Data collection over a year at Sungai Perak in Kuala Kenderong will inform effective catchment management strategies. Alright, next is about objective. There are three objectives of our project. First, to estimate the peak flow rate of runoff for a specified drainage area using the rational method and money equation. Second, to examine an appropriate rainfall management system that can handle anticipated peak discharge during storm events. And the last one is to determine and plot the unit hydrograph for the proposed catchment area.
I'll be outlining the methodology used in our study, focusing on the critical role of the Department of Irrigation and Drainage (DID) in Malaysia, the utility of Google Earth Pro, and the process of peak flow estimation in our catchment area. So the first one is Department of Irrigation and Drainage. They did in Malaysia pivotal in managing water resources for irrigation, drainage, flood control. They design, construct and maintain the system to ensure the efficient water delivery for the agriculture and develop drainage system to prevent waterlogging and salinity. So the peak flow estimation. Peak flow, the maximum discharge a river can handle during heavy rainfall, is critical for designing the effective of drainage system. We use two methods for this estimation, which is rational method and Manning method. This one is rational method. Rational method considered as the catchment size and the rainfall intensity to calculate the peak flow. The next one is Manning method. Manning method estimate the flow velocity and discharge based on the channel slope and the roughness. So the next one is Google Earth Pro. Google Earth Pro is a powerful tool for spatial planning and analysis offering high resolution satellite imagery, historical imagery, and advanced GIS data capabilities. In our study, we use Google Earth Pro to map the rainfall data and visualize the impact on specific regions. Last one is geographical characteristic. Using Google Earth Pro, we analyze the terrain profile, gradient slope, and the cross-section of the river at Station Hujan Kuala Kenderong, Kampung Tanjung Jerai Perak. The terrain's maximum elevation is 568 feet, with the slope ranging from 25.2% to 22.2%, and the average slope of around 7%, and the perfect slope was to be determined to be 7.5%. In conclusion, our methodology is integrate advanced tool and technique to effectively analyze the manage of the water resources and providing a comprehensive approach to irrigate and drainage and flood control in Malaysia.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Salim bin Sobri with my card metric number DF230149. Now I will present to you about rational method and Manning method. Firstly, for rational method, we have to find the running coefficient by referring information from table various land uses from MASMA 2nd edition 2012. By using the formula, we receive our value for C average is 0.40. Then we have to go back to Google Earth Pro to take note about the overland flow path length and proceed to the calculation for slope overland surface S. which is the value that we got for flow path length is 4.47 km and 1.36 for slope over land surface. Then we have to know the Horton roughness. From the table, which is our value is 0.060 densely graved. Next, we find the time of concentration by using the formula of the land flow, which is 1.66 hour that we have got. Then after we have found all the data, we can proceed calculate the value for rainfall intensity by referring IDF empirical equation from MASMA's second edition 2012, which is the value for rainfall intensity that we got is 93.16 mm per hour. And also we use the rainfall intensity data and find the peak runoff, which is 92.33 m3 per s for the area. Lastly, we need to use many method, which is the way for proceed to do the hydrograph for our data. We need to calculate the cross section for upstream, midstream and downstream. After calculate all the data by assume triangle shape for all three streams, the area value that we got is 573 m square for upstream and 709.5 m square for midstream and 360 m square for downstream. Also for the parameter value is 333.8 meter and 268.47 meter and 246.15 meter for three of them. After then calculate everything we have found, the value for the average peak flow, which is 3552.66 m cube per second, by dividing total discharge with the value of the stream. And that's all from me. Proceed to the other member. Thank you.
Now I will continue present about hydrograph. First, for the hydrograph, for upstream we get by using data from discharge, which is Q. We get discharge with 1 over value of roundness multiply area multiply radius power of 2 over 3 multiply slope power of 1 over 2. Then we will make unit hydrograph upstream and focus on peak and higher value discharge to find UH ordinate upstream, which is we get 5576 307.39 meter cube per second. For find value for UH ordinate, we need to use formula direct flow over total direct flow for upstream area, and we get 0.1592 meter cube per second per cm runoff. By the same method for midstream, we get higher value for discharge is 2823664.73 meter cube per second, and UH ordinate we get 0.19708 meter cube per second per cm runoff. Lastly, for the downstream, we also apply the same method and get higher value of discharge is 4118214.1 meter cube per second and UH ordinate 0.1 meter cube per second per cm runoff. The graph show about the rainfall and discharge at our river. By determining the discharge depend on the rainfall for the managing flooding, it could help the community to be more aware and take caution from any disease.
Alright, we move to the discussion. Flood occurrence in Malaysia, particularly during the northeast monsoon season from October to March, primarily impact Peninsular Malaysia coastal areas. Our research addresses the rising flood risks in Malaysia, which have surged due to human activities such as rapid urbanization, deforestation, and the conversion of forests into urban zones. Even inland regions, including Kuala Lumpur, face increases flooding due to intensified precipitation from climate change. Over a year, we collected water level and rainfall data, which was recorded in Microsoft Excel. This data helped design the catchment boundary, calculate mean area rainfall, peak flow, and river flow rates, and create hydrograph. To mitigate flood risk, we recommend establishing robust flood forecasting system, prudent land use planning, preserving natural wetland and floodplains, and investing in urban drainage infrastructure, implementing green infrastructure methods, and continuously monitoring and refining flood management strategy are also crucial to reducing flood risk effectively. For the last part, which is conclusion, in conclusion, flooding in Malaysia can result from both natural and man-made causes. Investigating flood patterns is essential to determine flood-prone areas and implement preventative measures to reduce damage and expedite recovery. Our study focused on Sungai Perak and Kuala Kenderong, a region frequently affected by flood. Over the course of 2023, we collected rainfall data, identifying the highest rainfall event in August at 48.5 mm, using sources like Department of Irrigation and Drainage and Google Earth Pro. By plotting unit hydrograph upstream, midstream, and downstream, we analyze the watershed hydrology response to rainfall. To mitigate flood risk, we recommend raising public awareness, educating communities on emergency preparedness and water conservation, restoring natural water retention features, and improving urban planning to preserve natural drainage patterns and avoid construction in flood-prone areas.